Hello, my dear students. So, here I have brought part 3, chapter 2 is matter surrounding us pure. Class 9 Science by your Sonali ma'am. I hope you will enjoy part 3, which is mainly focused to separation techniques of matter. Techniques which are mentioned here, these are the separating components of mixtures. So the components of heterogeneous mixtures can be separated by simple methods like hand picking, sieving and filtration, because you can already see the compounds which with the naked eyes, because which are moving here and there. But that is only possible with the heterogeneous mixtures. But what about the homogeneous mixture? How can you separate them? So there are various suitable special techniques which are used to separate the components of mixtures which are homogeneous. So the first is evaporation, second is centrifugation, third is decantation using separating funnel, fourth is sublimation, fifth is again centrifugation, sixth is chromatography, and seventh is distillation and fractional distillation. Now some of them you might be already you have studied, you might be knowing, and some we will discuss in detail. So here we go. So the first is evaporation. So now word itself says what is evaporation. So evaporation is something that the water which is on the surface level starts evaporating. That means it converts into the liquid to gaseous state. That water turns into water vapor. Here you can see in the figure, what do we have? We have a burner, tripod stand, we have wire gauze, we have china plate dish, and the mixture of salt and water. And you can see that we are continuously providing heat using burner. So this method is used for separating volatile component solvent from the non-volatile component, which is solute, by heating the mixture. Now volatile, that means it can move, and non-volatile, which are not so movable. Example, ink in the mixture of a dye and a water. If some ink is heated in a dish, the water starts evaporating and dye is left in the dish. Similarly, you can separate the mixture of salt and water or sugar and water by the evaporation even at your home. You take a 10 ml of water in a container, add a sugar or a salt, and you keep on heating on the burner. Eventually you will notice that what all water is there, it has been evaporated, and what you are left up with the salt or the sugar. So this is the first way by which you can separate the homogeneous mixture, which is so easy. It is evaporation. Let's talk of centrifugation. You can see the model here, centrifugation, which is like a fan. You can see the ceiling fan. So here there are the tubes which are kept on certain angles in the circular path or the rotational path. Now they are going to move, they are going to rotate on a very large scale, like certain times it is 600 round per minute. That means per minute they rotate for 600 times. And even the high-tech laboratories, they have centrifugers which rotates even to 2000 to 5000 rounds per minute. So what basically they do is, the liquid part will remain as it is, and what all solute part will settle down using centrifugation. Now simple centrifugation even you have seen at your place. When you use a blender to make makhan out of malai or the buttermilk, when you churn your buttermilk, all the butter that comes up, and what remain down is the buttermilk or the at the curd milk. Now the method of separating denser particles and the lighter particles from a mixture by using a centrifuging machine is known as centrifugation. For example, if we take some milk in a centrifuging machine and spin, that means rotate it rapidly, the cream separates from the milk, because cream is less dense than the milk, and that is the way you prepare white butter or white makhan at your home. This centrifugation is highly used for testing blood, because when they check certain diseases which are present in your blood or not, they use the centrifugation, so the serum stays up and all the RBCs and the WBCs settle down. So these centrifugations are highly used with the food industries as well as the laboratory industries. Now decantation using separating funnel. Now simple decantation you have studied in class 6, that what you used to do is you used to tilt your beaker and you used to perform separation. Here you are using a separating funnel. Now this method is used for separating mixture of immiscible liquids, that means they are not mixed with each other. So liquids are separated into two different layers depending on their densities. So in the figure you can see the kerosene and the water. So of course the kerosene is the oil with the lesser density. So it will float over water and water remains down or at the bottom. So if we take a mixture of kerosene oil and a water in a separating funnel, it forms the separate layer of oil and a water. The water can be separated by opening the top cork. You can see a tab like structure. You can just open it. So as in when water is going to get finished, we will close this cork, so that what we will left with the separating funnel is nothing but the kerosene oil. After the water flows out, the stop clock can be closed. So this way I can separate kerosene as well as I can separate the water. Now the fourth method is sublimation. Now for sublimation to perform, now first you need to remember what is sublimation. So sublimation is conversion from solid to gas without converting into liquid, that is known as sublimation. So in this method we use to separate the mixture of sublimable components from the non-sublimable components by heating mixtures. For example, if a mixture of ammonium chloride, which is NH4Cl, and common salt is heated. So here ammonium chloride is sublimable, whereas common salt NaCl is non-sublimable. So the ammonium chloride sublimates and can be cooled and solidified and collects, and the salt is left behind. So here you can see in the figure we are using burner, china dish, mixture of ammonium chloride and a salt we have taken in the china dish. I started heating this mixture. So ammonium chloride vapor starts forming and they go up, and we have covered this vapor using inverted funnel. At the end of funnel you can see a cotton plug onto which this fumes of ammonium chloride are going to get condensed back and they are going to get collected over there, and ammonium chloride is going to get solidified back. Now what it is going to remain in the china plate is nothing but the salt. So using the sublimation you can here separate sublimable compound from the non-sublimable compound. So sublimation definition you need to remember here that it is a conversion from solid to gas without converting into liquid. So here who sublimates? This compound ammonium chloride sublimates, form into vapor stage and collected by the cotton, and again it is solidified back to the ammonium chloride. Now here we will fifth procedure here we are going to discuss is chromatography. So the name you split chromatography. So chromato is a color and graphy that you are supposed to get certain lines. So simple chromatography includes chromatography paper, solvent and the solute that you are going to separate out from the given solvent. So here you can see in the figure that you have prepared a chromatography paper. You have allowed that paper to pass a solvent over it, so that blue ink will start flowing along with the solvent, and you can see the distance by which it can travel. So here the second figure you can see the components in that ink or the sample have 3 further subcomponents which have traveled like yellow, pink and sky blue. That means the sky blue substance is highly solubilized in the given solution. Pink one is moderately solubilized and the composition of yellow substance is quite less. So this is a chromatography paper and the chromatography technique. If possible, we will perform this technique in our lab. Now this method is used for separating colored components from the liquid by using filter paper, or you can say a blotting paper. Put a drop of ink near one end of strip of a filter paper and dip the end of paper in a test tube containing water, or you can use a alcohol or the suitable solvent. Now ink is a mixture of 2 or more colored components. So this components which is more soluble in the water rises faster and get separated first, and the one which are less soluble in the water will stay behind. So this way we can separate one or more or 2 or more substances from the solution using chromatography. Now let's talk about the distillation. Now you know what is the basic principle behind the distillation. Now in distillation you heat the water, it is converted into water vapor. This water vapor passes through the condenser which has the cooled water running through the surroundings. So this water vapor again condenses back to the pure water, and this is the process by which we prepare the distilled water, which is widely used for the preparation of chemicals and the laboratory cleaning. So this method is used for separating a mixture of miscible liquids by boiling the mixture and cooling the condensing vapor. So that is the principle stay behind the distillation. Now let's talk here about the simple distillation. Now this is used for separating mixture of two miscible liquids having sufficient difference in their boiling point. Now miscible, that means they can be mixed with each other. They should be mixed with each other, and in though their boiling point there should be a huge difference. So here to measure the boiling point I have used the thermometer during distillation. So if a mixture of acetone, which is a type of ketone, and water is heated, suppose I have a mixture of acetone and water, both are transparent by nature, is heated in a distillation apparatus. The acetone, which has a lower boiling point, let's say about 70 degree, will boil first, and then the water which has 100 degree Celsius of boiling point will boil later and cools and condenses, and this way they are separated out from each other. This is the example of simple distillation. Now here it is a fractional distillation. Now simple distillation you can use only two components, but for the fractional distillation you can separate the mixture of two or more miscible liquids with the difference in their boiling point is less than 25 Kelvin. So specially the fractional distillation is used for separating petroleum products from the petroleum. So the apparatus used for the fractional distillation is similar to that used in the simple distillation, except that the fractional column is fitted between the distillation flask and the condenser. So the fractional column has the glass bead which increases the surface for the vapors to cool and condense back. So here they will fastly condense back into the liquid, and so they can be separated fast. So here when the mixture components have less than 25 Kelvin of boiling temperature, boiling point difference, you can use the fractional distillation. The fractional distillation is used for separating components of petroleum, as I told you, separating the different gases from the air. So here they will have the round bottom flask, they will take the mixture and they are using Bunsen burner. At the same time they are using a fractional column and the thermometer. So one by one at the different boiling temperature mixtures are going to get heated, convert into vapor, and this vapor is going to pass through the condenser which is kept in the slanting position. This cools down back and form the different mixture separations. So after one or another, you can separate petrol, kerosene, crude oil, grease oil from the mixture of petroleum. It is very important procedure for the separation of the mixtures. Now let's talk about the separation of components of air. So how will you separate the air components? So air is a mixture of gases, as you know. The components of air can be separated by the fractional distillation. Air is compressed by increasing the pressure and cooled down by decreasing the temperature to get the liquid air. So first you are increasing the pressure, and at the same time you are cooling it by decreasing the temperature to convert that gaseous air into the liquid air. This liquid air is then allowed to warm up slowly in the fractional distillation column, and then the different components are separated at different heights depending on their different boiling points. So here you can see in the air flow chart, air is compressed first and cooled down by increasing pressure and decreasing temperature. That air turns into liquid air, and this is allowed to warm up slowly in the fractional distillation column. And so the different gases like oxygen, nitrogen, carbon dioxide and helium and hydrogen, they are separated at the different height. Now boiling point of oxygen is 183, argon 186 and nitrogen is 196 degrees Celsius. At different temperature they are going to boil, and we will get those gases at different height level. Now purification of solids by the crystallization. I hope you must have remembered the activity in class 7 in which you used to perform the crystallization using crystals of copper sulfate, which were blue or violet in a color. So the crystallization is a process by obtaining a pure solid in the form of crystals from its solution. So simply, example is crystallization, we can obtain the pure copper sulfate from its solution. So here for the activity, what you are going to do is you will take the 5 gram of copper sulfate in a minimum amount of water, filter the solution to remove any other impurities, evaporate the solution in the china dish using the first activity using Bunsen burner to get the saturated solution. Cover the solution with the filter paper and allow it to cool. Now at the end what you will get is the pure copper sulfate crystals that are formed. You can see in the below image that you can see the second image, that is the pure copper sulfate crystals that you have obtained from the impure copper sulfate solution. Okay, so these are the various separating techniques that we have discussed. You might have remembered class 6 separation techniques which were done on the physical task like winnowing, sieving, filtration, then hand picking. So that was only possible when the solute or the mixture in which you are supposed to separate is visible. So here we have performed all the separation techniques in which components are connected with the chemical means, and somehow the solutes are not so visible from the solvent. So this all separation techniques you are going to remember, as well as you will write the notes on each and every separation technique. I'll bring the next chapter with my next presentation. I hope you have understood chapter 2 class 9 science. For the further query you can revert me back on this. Thank you.